Okay. Hello, everyone, and a massive thank you to all of you for coming and attending. I'm Amira. I'm a member of Black Voices, and this is today's event, Coded Bias, Can Coding Be Racist? Firstly, can I say a massive thank you to Jasmine for organising this event and liaising with our panelists, and also to Tom for helping to make everything happen. During the talk, if you have any questions that you would like to ask the panel, please put them in the Q&A or in the chat, and we'll have a Q&A section at the end of the talk. So today we are here with Dr. Iran Mansouri, we're here with Dr. Mohan, and we're here with Immacula from the School of Business. The other two are from the School of Computer Science. So our very first presentation will be from Dr. Iran Mansouri, and it's a 10-minute presentation about bias in AI, technological determinism, and how technology anchored to a historical present.
Hello, thank you, Amira. It's wonderful to be here, and thank you for the invitation. So let me start with a very short introduction of the, sorry. Do that. Yeah, my slide should be visible now. Can you see my slide? Can someone confirm that? Excellent. So before anything, I have to start with the fact that I really like the name of the event because it's not about AI, machine learning, or big data, or any particular method. And rather it uses another umbrella term, and that is code, to discuss about bias. And of course, being an academic, I'm sensitive to wording, and I would like to emphasize before getting to anything that bias should not inherently have a negative connotation. And this is because as humans, we are making decisions in our everyday task based on the cognitive bias we have. So, but I want to emphasize here, which I assume that most people here agree with me, we are talking about harmful biases. And a famous example of such biases, which most of you probably heard about it, is compass. In case you haven't, let me briefly explain what's compass. Compass is a decision support tool developed at Northpoint and is used by US court to assess the likelihood of a defendant becoming a recidivist. What happened was that after deploying that, a group of journalists discovered that the Compass score, which uses a predictive model for the risk of crime recidivism, has a strong ethnic bias. Indeed, according to this score, a Black who did not reoffend was classified as high risk twice as much as white who did not reoffend. And white repeat offenders were classified as low risk twice as much as Black repeat offender. And as you see, this is really clearly the case of Dylan and Bernard. Bernard is classified as high risk despite the fact that there is not subsequent offenses by him. One of the important questions we should ask is why this happened. And the short answer I would like to give is actually we don't know. We have a strong guess, but we don't know. And the important reason for that is that most models are not interpretable. What does it mean? It means that most models, they don't have the ability to explain or provide any meaning or explanation in understandable terms to a human. And this is a big issue. But I will skip talking about it and leave it to Mohan to elaborate the issue further. But let's assume we know exactly why the compass system makes such a discriminative and biased decision. And that is because the database on which the model is trained indicate more Black is more probable to commit crime again. So if it's the case, one might say, this is what data said. So what is your problem? Or perhaps an AI technician or a data scientist might tell us, our model is 95% accurate, and the decision made by human is faulty sometimes. Exception happens. So what is your problem with it? Okay, what is our problem with it? I would like, I wish this panel was a bit interactive, and well, if it was face to face, I can ask people, okay, what do you think? And what are the biggest issue with this? But that would be a long list, I guess. But I give my own opinion and only focus on actually 3 problems here among the long list one would make. So let's start with the most obvious problem. If you think about it, what happened is quite simple. And this model clearly consider race as a decision factor. And what happened is by putting more Black and minority in jail, the model becomes even more biased than before. It basically perpetuates and reinforces the assumption. And that's quite, the common problem that always everyone explain. But there is another thing, is that such system also acts as a self-fulfilling prophecy. For example, by putting a breadwinner of a family in jail, you expose the children of that family to extreme vulnerability. So as a result, they may become even more exposed to commit a crime. So if the algorithm makes this discriminative decision to many Black community residents, let's say, not only the model will be even more biased to certain area or race, to be crime prone, and also may change the society in the long run so that it proves its accuracy. So it acts as a self-fulfilling prophecy. Another issue is technological determinism. Unfortunately, we as a society, and specifically politicians and many scientists, have this great tendency about thinking as technology as endpoint. We are not questioning where we are. We are only thinking about where the technology takes us. And we have this technological determinism in mind to fix deeper structural problems like growing inequality, social and racial injustice with technology. And there's a good reason for that, in fact. And the reason is the mathematics is complex enough for general public not to understand, therefore don't know who to blame or held responsible. But at the same time, the mathematical model is simple enough to apply in a caricature or simplified context. So what usually happens is that we say we use this model to fix the problem and no one blame us, problem solved. So, and I guess a good example of this would be the UK A-level last year. And another thing that I wanted to point it out before ending my presentation is the fact that technology is often anchored to a historical present. Most of us think about technology as something new, fresh, and perhaps the compass tool using that court system was new, but we often forget is the context in which that technology is applied has carried out, basically has carried the long history of racial injustice. And this is related to the point I made earlier about using technology as basically a temporary patch for a deeper structural problem. So, and I would like to read a part of open letter from Black in Computing, and which basically said what is all need to be said. As scientists, technologists, and engineers, we are told that there is no need for culture in our field. Ones and zero. The scientific method and meritocracy from the basis of our discipline, where computing is a neutral entity. We know this is not true. We know that our field does not exist in a vacuum. We see AI and big data being used to target the historically disadvantaged. We see machine learning systems that routinely identify Black people as animals and criminals. Algorithms we develop are used by others to further intergenerational inequality. And my last slide is how to move forward. I put one as, we need more advances in AI and machine learning method. But this is the one I usually give in the scientific venues to encourage my fellow scientists, to really think about the methods. They can be more explainable, interpretable, and so on. But what is really I want to focus here is we shouldn't be moral death blinded. In our running example, we shouldn't ignore the legacy of injustice in judicial system, and we think that the algorithm must address it. That will never happen. In fact, we know that it only perpetuated the practice. We have to pay our moral debt, and basically we have to move forward with the past. Past basically never passed. We have to carry on the past with ourselves in order to make progress. Thanks.
Thank you so much for your presentation. That was really, really interesting. And now we will be looking at Immacula, who will be speaking to us about addressing coded bias, law regulation, and principles for responsible artificial intelligence.
Good afternoon, everyone. That was really a great introduction by Iran. I'm just going to share my slides with you so I can get started. Sorry, give me a sec. Let me get to the slides. Everyone see this all right? All right, so today I'll be talking about sort of moving on from what Iran mentioned, talking about what strategies we've put in place in law and regulation to address kind of the issues with coded bias that Iran has raised. So my name is Immaculatemotivation. I'm currently a research fellow at the Lloyds Banking Group Center for Responsible Business. Prior to this, I was at the law school where I was a postdoctoral research associate in blockchain and healthcare, excuse me. And my PhD was at Warwick Law, and it focused on cryptocurrency regulation. So my overall research focus is on emerging technology, but I've kind of segued into AI and starting to think about AI from a business transformation perspective. So my presentation will first talk about the challenges of regulating AI, why it's so difficult and why it's an issue. And after that, I'll talk about what the relevant AI laws and regulations are. And I'll conclude by talking about ethical guidelines for trustworthy AI with a focus on non-discrimination and fairness and on diversity. So AI is particularly difficult to regulate, particularly because law is often playing catch up with emerging technology. I saw this when I was looking at Bitcoin. It's literally at least a decade behind the innovations and is always trying to play catch up. So some of the factors that make it difficult for the legal system and to develop a regulatory framework around AI has to do with the enhanced security risks due to the connectivity and openness of AI systems, how these systems are so dependent on data and the need for neutral and accurate data for AI training, the level of autonomy, certain level of autonomy of some AI decisions, the opacity of the operating systems, complexity of the product systems and value chains, as well as gaps in product liability laws, which don't fit the autonomously deciding AI systems. So they've been generally based on general fault-based liability rules, and that is totally incompatible with the way AI systems currently work. So what are the existing laws and regulations around AI? The short answer is not much at the moment. So a company called Cognilytica last year did a survey of worldwide AI laws and regulation, which gave an overview of the latest legal and regulatory actions by countries in these 9 different areas. So the report analyzed things like facial recognition and computer vision, operation and development of autonomous vehicles, issues of AI relevant data privacy, challenges arising from conversational systems and chatbots, the emergence and possibility of lethal autonomous weapons systems or laws, aspects of AI-supported decision-making, the potential for malicious use of AI, and other general regulations based on laws and on the use and creation and interaction of AI systems. So you will notice that AI ethics and bias was flagged as an important area that the regulations need to cover. But what's clear is that a lot of governments are adopting a wait and see approach to regulating AI. The consensus is that it's still too early for lawmakers to see just how this technology impacts citizens. But leading the drive for AI laws and regulation is the European Union. Whereas on the other hand, the US takes a very light wait and see approach. The EU has existing or proposed rules in 7 out of these 9 categories, the strongest of which is obviously in data protection. I'm sure you've all heard of the GDPR, but this is really important because the use and discussion of data goes hand in hand with conversations around AI, because AI is fueled by data, is data-driven. So laws concerning data is particularly relevant since those laws can impact the use and growth of AI systems. However, if you check on what the data says, AI and ethics and bias is still very little action around that in terms of laws and regulation. A lot of regulations have been put for autonomous vehicles, particularly as a lot of countries are thinking about greening the economy. So they've put in place sort of a regulatory framework around the use of autonomous vehicles, but we're still very much behind in having tangible laws and regulations. So focusing back on the EU, which has the most comprehensive set of regulations around AI, or making the first initial steps around that. And relevant to this are 3 EU Parliament resolutions that were issued in 2020. One of them is a framework of ethical aspects to artificial intelligence, robotics and related technologies, a civil liability regime for AI, intellectual property rights for the development of AI technologies. But you must note that these resolutions are not legally binding. However, they do express political commitments or positions on what they want to regulate in the future. So out of these 3 resolutions, 9 key topics were raised. So these includes things like explainability of AI, functioning and decision-making, having ex-ante conformity assessment and labeling schemes, having human contact points to address the system, addressing the technical robustness of AI, accountability, liability, and burden of proof, and human control mechanisms and risk assessments, to mention a few of them. I'd like to focus more specifically on how these sets of principles relate to ethical guidelines and trustworthy AI. So the European Commission has a high-level expert group on artificial intelligence. If you want to know someone on that expert group, she's in the law school and her name is Professor Karen Young. So what they did was they came up with this set of ethical guidelines, which in lieu of hard law, act as sort of scoping for future laws and regulations. And they focus on key areas, including accountability, human agency and oversight, technical robustness, but most importantly, on keeping an eye on diversity, non-discrimination, and fairness. So when it comes to diversity, non-discrimination, and fairness, they came up with a checklist for developers to go through as they building these systems. So what are the sources of decision variability that occur in same execution conditions? Do such variability affect fundamental rights or ethical principles? How is this measured? Is there clear bias for trade-offs between conflicting forms of discrimination? Is this relevant? Is there a strategy in place to avoid creating or reinforcing existing biases in algorithms? Are processes in place to continuously test for such biases during the development and usage of the system? And finally, is a clearly communicated to whom and to what group issues related to discrimination can be raised, especially when these are raised by users or others affected by AI systems. They also bring up a focus on this diversity imperative. So a quote from their report talks about how diversity and inclusion play an essential role in AI systems. So it's critical that as more AI systems perform tasks on their own, that the teams that design, develop, test, and maintain these systems reflect the diversity of users and of society in general. This will lead to more objectivity and a consideration of different perspective, needs, and objectives. Not only are they talking about diversity in terms of race, age, culture, gender, but also in terms of skill sets and professional backgrounds. I sometimes wonder, I don't know if anyone who's listening and Black has ever taken a selfie with a Snapchat filter standing next to a white person. Hashtag if you know, you know. But it just begs the question if within the team of developers creating these algorithms, there were any Black people at all, or people representing enough of a demographic to be able to kind of feedback on, you know, how well these things are working. So in conclusion, the positive thing is that the existence of coded bias has been flagged and acknowledged in all the resolutions and future development of laws and regulations around this. So it has been flagged as an issue, and that's always a good first start. However, there are challenges that make regulating AI particularly difficult. So don't foresee in the medium term to have sort of a set of hard law around AI. We're seeing movement in certain areas, but there's still a long way to go. So this means that we rely mainly on codes of conduct, standards, principles, and things like that. The EU is leading in this area with the recent resolutions I mentioned, and the EU has a set of experts that develop these guidelines for trustworthy AI relating to non-discrimination, fairness, and diversity, which are the three areas that are particularly relevant to coded bias. So this is my last slide because it's a beautiful picture, but also because I wanted to use it to make a final note, which is linked to something, to emphasize something Iran said, which is that debiasing humans is harder than debiasing AI systems, which means that biases in algorithm are a reflection of the biases in society. So while they are technical solutions, this presentation focused mainly on just the legal and regulatory aspects. Thank you.
Thank you so much for that presentation. That was really interesting and very informative. So next up, and last but not least, we'll be having Dr. Mohan talking about his presentation on the bias and transparency in AI and ML methods, research and education challenges.
Okay, can you give me a voice check? Can you hear me?
Yeah, we can hear you.
And just another check, can you see the slides? I mean, I don't have much in terms of slides, but can you see them?
Yes, we can see them.
Okay, cool. So my name is Mohan Sridharan. I'm an academic, like many others in this university in the School of Computer Science. And what am I going to talk about today? As the title says, I'm interested in bias and transparency in AI, that is artificial intelligence, and ML, that is machine learning. And I'll come back to why I put them as separate, and research and education challenges there, right? Okay, cool. Just the first one bullet of saying what perspective am I bringing here. So I do research and teach topics related to artificial intelligence, machine learning, and robotics. And this I do here in the School of Computer Science. So I look at issues related to cognition, learning, reasoning, and sort of like, manipulation in the context of robots. And to do this, I develop methods that would be classified as being artificial intelligence, AI methods, or ML methods, right? And these days we hear about these a lot, right? Like to the extent, as the other two speakers talked about, to the extent that they use so widely that we are also starting to slowly see some interest in regulations and stuff and how to regulate the use of these methods when they are used in the context of humans, or when the effect of these algorithms can influence what happens to humans. So to the extent that these days data information is the sort of like, the key thing, the key commodity that people trade in, right? Like, and these are used to make a lot of decisions. And I think as Iran mentioned before, the inner mechanisms are not transparent. So, and why is this, right? Like, we don't know why the algorithm says what it does, or often we don't know why exactly, or why it did not say something else. What exactly did this algorithm or method do, or how did it arrive at these conclusions? So part of this problem is, as I list here in terms of challenges, like, increasingly these methods and other things have become data driven. And I would like to maybe briefly talk about what I mean here. So initially the goal of AI, so if you go back to say the 50s or before that, it's even called, I think, cybernetics, was to try and create these computational models or computational artifacts that try and, in some sense, mimic the behavior of human beings, right? Like, try to get it at the level where it could, like, reason, learn, act like human beings, right? And to do that, they decided that a large component of that is also like, some kind of prior knowledge, some kind of prior beliefs that human beings have, and which motivates their decision making. So from there, over time, these days, it has become to the extent that AI has become all about data, right? And this is unfortunate. And oftentimes, even researchers do not know that that's not what AI is about, right? That's not all what AI is about, right? And so, if it's largely data driven, the examples that we give in class when we teach a very basic course in robotics or AI is, imagine I gave you a coin and I said, okay, how likely is it that this would give you heads or tails? You would look at me and go, 50-50, right? But imagine if I said, no, no, you can't make the decision that way. You're going to flip the coin 20 times and then tell me how likely are you to get heads or tails. Now, if the same coin sort of comes up with, say, by some happenstance, comes up with, say, 17 heads or tails, you're going to come back, or 18 heads or tails, and two times it comes out with tails, you're going to tell me, oh, this is a highly biased coin. This only comes up with heads 90% of the time. Sorry, it comes with heads 90% of the time. Very rarely does it show me any tails, right? But this is a flaw not in the coin itself. The coin, if you tried it sort of several more times, would probably balance things out. But it's largely because we made our decisions based on a certain data set, right? So the interesting question to ask is, where exactly is the bias? The bias, oftentimes people tell us this is algorithmic bias. Like, that's a term that is thrown at researchers. But you have to understand the algorithm by itself does not have a bias, right? The algorithm is written by a human being. There can be bias in the data that you use to draw these conclusions. And that's the standard term we use in drawn from something else in computer science. Is this GIGO, garbage in, garbage out. You give it incorrect or biased data, even the best algorithm in the world can do very little with it, right? What then happens is it ends up reinforcing or perpetuating the bias and other flawed decisions, right? Like the excellent examples that the other two speakers had, right? If you take a software and sort of like, it keeps on coming up with certain people being criminals or otherwise just based on their race or like, skin color or something like that. Now, what's going to happen? You're going to say, oh, this is an excellent algorithm. It's helped me find all these people. And look, it always comes with this. So obviously, these are the people who must be the criminals, right? So it does, this is sort of like, like you call this like circling the drain, like, you sort of reinforce negative things, and that can lead to other more negative things. And it's not just, if I can again refer back to something that I think Iran was mentioning, like, bias is not just negative bias, right? So this notion of accountability and equity, right? Like when you use these algorithms and use that to determine who gets what resources, it can also do other things, right? It not only does it sort of give you a skewed distribution of blame, it can also result in a skewed distribution of benefits, right? People who truly need something may not get what they want. So there are several challenges. And the key instance or problem here is that when they develop these algorithms, oftentimes because of this push to try and, you know, uh, uh, because of the economic or other aspects involved, there is this push to also make these algorithms apply. And researchers oftentimes don't sit back and think, what are the consequences of the decisions that's happening, right? So this is thought in sort of like, legal things, and maybe Immaculate knows this much better than I do. It's like, bias is not something uncommon. Each and every one of us has biases, right? That's what defines us as human beings. One of the key things. We think certain things are right, certain things are not right. The important thing to be able to face up to that bias and try to find ways to sort of address it, right? When it's negative, when it's not resulting in a positive outcome. But researchers oftentimes, like, they're solving on these problems in this sort of kind of this cocoon, and that results in a whole lot of problems, right? So these days, for instance, as I said before, it's largely data driven. People tend to throw terms like deep learning, data science. So all this essentially means is you throw a large data set at this like, big computational model, and it comes out with answers. And if it comes out with high accuracy, you don't bother to sit back and think, why exactly did it do that? I'm not saying nobody does it. There are several people starting to look at this problem, but we don't yet understand. But these systems are already been deployed out there, making decisions that in a strong way influence and determine what happens to humans, right? So that's a problem. So what we need to have is some sort of balance and say it's not just about data, and also have some strong consideration given to what are the consequences of the decisions, and to think and carefully explore why these decisions were made, right? And that brings me to my second and last slide. So one thing you could do, what are some things that need to change, right? First, you need to encourage different perspectives, right? And widen participation. And this is not just in the context of AI ML algorithms. This is in general, right? In sort of different disciplines and other things. And you need to go engage with the people who are going to be influenced, or who are going to have to face the effect of the algorithms and other things you develop. Right? And the more you engage in these kind of things, the better it is to understand that there are real world consequences of what we develop. The second thing goes back to what I was saying a few minutes ago, a couple of minutes ago, is you need proper training in the use of these AI ML methods, right? And this might seem strange, right? With this sort of push to, publish the next paper, show the next result, show the improvement, and other things than that. It's often difficult for this to maintain this key concept that is required, or this key attribute that's required in all work at the university, right? Scientific rigor and integrity, right? People often don't learn from history, and I don't mean history in terms of human history alone. Even if you take a very small part of, say, the development of AI, right? Many people, even researchers in AI and machine learning, oftentimes don't know the difference between the two, and oftentimes do not realize that this current trend of basing everything on data is actually a more recent trend, like in the last decade or two. And that is not what AI is all about, right? So there is a lot more to AI than just using data to make decisions. It is a new development, relatively speaking. But so what happens then is we end up making the same mistakes. And now you may ask, okay, so if researchers know, what stops us from making sure that this does not happen? The key thing is with the sort of so-called changing demand, is the change in curriculum, right? Instead of the education and curriculum at the university informing and guiding what students need for the future, you're basically going for the short-term benefit and saying, oh, this is what seems to get them jobs. That may or may not be true. I would argue that that's not necessarily true. But even then, what happens is a lot of the modules themselves, the kind of modules that used to teach the history of AI, or like the broader machine learning modules. Thankfully, for instance, the School of Computer Science at the University of Birmingham is not in that category, as in we do teach many of these things. But broadly speaking, this is not true. So many students don't learn these things. So as a result, the methods that they develop are very narrow and focused, and they don't understand this notion of bias and other things until they either go out there and start developing algorithms, say for a company or some other institution, or like when they say, unfortunately, see the effects of some such algorithm being used, right? And the other thing I would say in terms of education is that these attributes that we care about, things like this accountability, fairness, I would draw a parallel with security, right? When people develop algorithms and they say, okay, this should be secure, security is a key concern here. If you try and tack this, and people who understand computer security know this, if you try and tack this on at the last minute and say, here is an additional module that will make things secure, that hardly ever happens, right? This is like saying I build a sort of like, a big house, and I don't make sure the the construction itself is strong and can withstand whatever natural elements that can be there. And then in the end, I say, okay, the house is secure. Here, I gave you a nice big lock. It doesn't work, right? In the same way, the attributes that you want, like fairness, accountability, students and sort of researchers must be trained in thinking about these things at all levels, not just at the end, right? And then should be trained also to think about how what they do affects what happens, if I can use this word, out there. And these kind of changes I'm talking about needs to happen at all levels, and that's why I call them structural changes, right? So oftentimes, if you take universities or other institutions, you will see these policies. Like for instance, someone would say, okay, let us decolonize a curriculum, right? I mean, this is a big thing in universities in the UK and elsewhere, right? But that's not enough, right? It's actions and not policies that cause changes, right? Just having policies hardly ever results in any meaningful change, right? That's a step. It's a good step, but it's a first small step, right? What is really needed are these actions, right? So like for instance, if you look around campus and you say, okay, fine, let us take any of these things, like broadening participation. Let us learn about like, what not just sort of certain key scientists, but like, different scientists from different backgrounds, what kind of contributions they've made to AI. Let us try and understand, like, how we can do certain things that we really care about, like, say better sort of like, climate justice or decolonization, all these sort of key things, right? You will notice that universities around the world, including University of Birmingham, will have policies for these. But in terms of actions, it's very difficult to make that happen unless we all sort of organize and band together, both like, students, like, the lecturers and other people at universities and in the broader society. And we try to bring about these changes, right? We need actions again that will actually make these things happen. And when such things, people try to make this, to encourage them strongly. And that with that probably key thing, I would probably end here and say thank you.
Thank you so much for that. That was a really good presentation. So now we'll be opening up for any questions. I have a few questions that people have already submitted before the talk, as well as some of my own questions that I'd like to ask the panel. So please do drop any questions in the Q&A, and I'll get started on some of the questions that we already have. The first question, and this was actually briefly mentioned in Aaron's talk. So right here it says, what do you think about artificial intelligence and its involvement in this? Take the A-level algorithm used last year, which meant students at poorer or worse schools had an extremely high percentage of not getting a top grade. And the advanced students with small class sizes, et cetera, at private schools were at an advantage. And it discriminated based on wealth and therefore against BAME people indirectly or otherwise. So what do you think about that and how to change that?
Yeah, so I give this as an example of a technological determinism in my talk. I think the A-level exam is a really complex problem. And if you have a complex problem, which has a lot of, intersectioning factor, like, the area you are in, the type of a school, like ethnicity background, and a lot of different issues, and all of them are going to be resulted in one simple algorithm, which I assume that you look at the historical data from the previous year, that obviously is a massive simplification of the problem. And what I really think is we should really stop to solve our complex societal issue with technological fix, be they this A-level or other issues related to pandemic. As Mohan said, we need a structural rethink and changes and rethinking about things that is actually complex, and an app or software cannot solve these issues.
Thank you. Mohan, is there anything that you would like to say on top of that?
Come on, don't put me in a spot. I was just joking. So, okay, I will, since I did joke about this, I'll say, so I would probably give a sort of short high-level answer of saying that that was just a bad algorithm, right? And second, I would just add on to what Iran has already nicely mentioned, that before you solve something so complex, you need to think carefully about the problem. And before you implement whatever algorithm you come up with, you need to think carefully about the consequences. I mean, what is sort of like an appalling or sort of like unbelievable is they not even bother saying, okay, let me run this test and see what comes out of it. Learn a test. I mean, the basics 101 that you teach in sort of like, basic development, like, it's like, you try a small test trial set and see what happens, see if it makes sense before you roll it out on a massive scale. It looks like they didn't even do that. So like, it's just very bad, how to say this, implementation.
Yeah. So our next question, this actually relates to what you were talking about in your talk, Mohan, about engaging with people that feel the consequences of these algorithms. This question is, do you think having more people of color or people from those backgrounds in leading roles within the teams that are making these algorithms will have an impact? Or does there need to be some kind of standardized moderation across all companies and all people? This is open to anyone to answer.
So, okay, since you said, I'll go first. So in general, improving having diversity and different perspectives will definitely help, right? Like, it always is. I mean, so there are some, and I should say this, like, I don't agree with that, but there are some who say that, oh no, like, the system is already designed to anybody who has has the merit will come up. So the system unfortunately is not designed to be equal for everyone, right? So anytime where we can promote diversity, give people opportunity, which is why it's equity and not equality, right? And so give people the resources they need to succeed and bring them up, and there is something to be said for the experiences they've had and how it informs the kind of decisions that they make, right? So having the diversity, definitely yes. But I would also say that we can't just stop there, because I think it was Immacula who said it's a bias is just something that is there, right? And it just manifests itself when you try and apply these AI algorithms, when they design this and use the kind of data that they use. So we need to also engage the broader community and get them to face this and say, look, the kind of beliefs and other things that you've had, the kind of things you're using to make your decisions, these are flawed, and this is why this is true, right? So I would say yes to what the whoever asked the question, but I would say that we don't stop there. We need to do something broader as well.
I can follow up on that and just give you the example of Tinit Gebru. She was working at Google.
Excellent example. Go on.
Yeah, and she kind of pioneered and kind of blew the whole tank open around ethical AI and started Black in AI, which is a really good organization to follow. And linking up with the structural issues that Mohan raised, I would encourage things like there's an organization called Code First Girls that sort of encourages females to kind of engage more in the sector and things like that, and take up those opportunities that are presented, just so that it's fair enough to ask that there's more diversity. But if there's not enough skilled people to take up those positions, it's a bit pointless. So I just encourage the community as well, sort of get more into this area with whatever initiatives are out there, although more are needed.
Thank you. So here's another question. You mentioned that countries aren't acting upon making more regulations for AI ethics and bias. And do you have any ideas of what tangible laws would be effective in reducing this bias? Or how serious do you think it is that we act upon this rapidly or soon?
From my experience looking at regulating blockchain and crypto from the beginning, the regulations and the laws come into place at the point where they are, unfortunately, the realistic assessment is when they create sort of tensions within sort of political and economic spheres that are enough to kind of push that regulation. So I showed how electronic vehicles and regulating those is now sort of top on the agenda, and most of the action is taking place in that area because it links up with other wider policy objectives around greening the economy and things like that. So I think realistically speaking, it will take a while, and it's very difficult to kind of create a regulatory framework around something that the regulators don't understand fully yet. So that's why at the University of Birmingham, there's a new program that I'll be launching that has law and technology, like law and computer science, for example. So it's a cohort from programs such as that are in a really good position to then push to legislate in this area because they have the combined skill set. So it's still a long way to go. And unfortunately, it's also driven by other external factors to the actual problem at hand.
Thank you. We have a question in the chat. So to what extent do you agree that the most important thing when it comes to reducing AI bias is to thoroughly scrutinize the data sets used in ML? Or should we use simpler AI techniques like decision trees or KNN to improve transparency in its decision making?
Could I try to go? Or?
Yeah, you can take that one.
Okay, so this is Mohan. Okay, so okay, yeah, my video stream is bad, so that's why I don't keep it. Okay, so the key thing here is is it okay? So I would partially agree with saying that scrutinizing data and examining that is a key thing that we are, any researcher who works in this area is trained to do, right? You look carefully at the problem, look at the data that you have, and look at the problem that you're trying to solve. That care is important. But I would say that it's not just that you want to use simpler AI techniques. That is the part probably I would not agree. So I would say that yes, some of these, and they are not necessarily simple, right? Decision trees have solved really hard problems as well. But so the second part of the question, I would say that you need to think carefully. Sorry, for the first part of the question, I would also say that you need to think carefully about the problem and what you're trying to solve, and see if the data reflects the problem that you're trying to solve. So that part, yes. The second part, it's not just that the techniques need to be simple. We need to put some care into figuring out what the technique is doing and trying to understand what decisions it's taking. Now, that's not just a factor of how uh, sophisticated the technique is. There are some really mathematically sophisticated techniques whose operations we understand well. But oftentimes, especially in these days, machine learning or sort of AI is conflated. With this notion of taking these large neural networks, in which case we don't truly understand what goes on in there, right? So it's not just that the technique needs to be simple, but we need to pay some careful thought to what exactly is the technique doing and trying to understand why and how something is being decided before we start rolling it out in the sort of real world decisions. I'll stop.
Thank you. Okay, so here's another question. Do some of the heavy biases we see in outcomes indicate that there are some questions that cannot be answered with code? Put simply, are these challenges like reoffending likelihood modeling solvable problems?
I would like to answer this question. Before to answer this question, I would like to talk about a little bit of my own research. So I forgot to say that I'm in School of Computer Science, and I'm mainly robotic and AI researcher. And also I'm interested to see exactly what Muhan just mentioned. So I'm interested to see, taking some concept from social sciences, whether they can or they cannot be represented and reasoned by some AI technique. And a particular example of that, which I'm really interested in and is related to this question, is culture. So in one of my recent work, I look at what culture means in anthropology, and I look at some classical AI method, and look at what is it possible with those AI method, with those knowledge representation and reasoning technique, is it possible to formulate culture, with those method or not? And I really look at the technicality of that. So back to this question is, I can't give the answer because I think this is a research question for every problem, for every concept. Let's look back to the culture. Culture means different things in psychology, means different things in linguistics, it means different things in philosophy. If you take a definition of culture, if any of these concepts, and then we look at the pool of AI method techniques, which is so many, several of them mentioned by the previous person who asked the question, we have to look, okay, is this method capable of reasoning and making decision based on this problem or not? Is it computationally efficient? Is it, we call it epistemologically, actually, is a good term for that. And each question has to be individually really audited with respect to the certain method. And I personally have a tendency of putting, not solving every problem, especially the deeper structural problem with technology. And I think the technology should be in place in area, I don't know, such as the area that are really dangerous for human to work with. But that's my personal opinion. So obviously I don't want to gear all the scientists in AI and technology to do what to do or not to do. Okay, I'm
I can follow up on that unless you have a lot of questions. Just to quickly say that you can, for example, use AI really well for sort of reporting suspicious transactions automatically on, in a fintech context. But if you transplant the same technology to like A-level results and things like that, so I think it needs to be purpose-driven in a discrete areas where it has sort of less of a negative impact. and there's more practical applications than others. So just to use that discretion in terms of, you know, where best the algorithms can be deployed for maximum value and least sort of damage.
Thank you for that. Another question here. I think it's fair to say that, like, when you were talking about Compass, I think it's fair to say that the proportion of Black men in prison, especially in America, is disproportionate to the crimes taking place. And do you think that has had an implication, that disproportion, on the results of the Compass and recidivism algorithm?
Well, my short answer is we don't know really, but I strongly suspect, as I said in the talk, I strongly suspect the case. But despite of the fact that I strongly suspect it is the case, I think there are really large issues with this, and it shouldn't be used an excuse to, use this in the first place, let alone, making such a discriminative decision. And I only named 3 problems which I had with that, which I'm sure that, this is a famous problem. So a lot of people actually comment on these issues. So many.
Artificial intelligence has previously presented issues in recognizing famous female Black figures as male. Do you think that this further reinforces preconceptions and stigmas that we already hold within our society? And should we be concerned about the repercussions of that socially for our future? Anyone can take this question.
Should I go? If no one else wants to, I can. Yeah. Okay. How do I put this? Okay, can you give me the exact wording of the question again, please?
No problem. Artificial intelligence has previously presented issues in recognizing famous female Black figures as male. Do you think this reinforces preconceptions and stigmas that we already hold? And how concerned should we be of the repercussions of that in the future?
Okay, so the actual question is easier to understand, like, yes and yes. Yeah, so it does reinforce, unfortunately that's true, right? The way these methods are being used. I'll come back to something else, which is why I wanted to listen to the question again. But yes, if we sort of use algorithms as they are without paying careful attention to what's going on, it does reinforce this. And especially, like, if you go to in sort of policing and other things, right? Once you start the algorithm and you sort of take, say, use it 3 times, like, and say, sorry, 10 times, and 9 out of 10, it makes the right decision, right? You're going to say, oh, the algorithm is doing the right thing, right? Without thinking that when the 1 or 2 times when it makes a mistake, it makes a very serious mistake that seriously, like, has a bad effect on somebody's life. So it's largely this data driven, right? Everything is data kind of thing, right? And should we be very concerned? Yes, we should be, right? Because the way this is being used is, like, it's not just, like, especially the way, because it's not very accurate, it does not just affect people, like, who are actually doing something wrong. It affects all of us, right? And we as a society should take this very seriously. But I'll come back to the first premise here, right? So these are, I would say, I mean, this might irritate some AI researchers, these are badly designed algorithms, right? There is no other better way to say this. These are bad algorithms designed by people without thinking carefully, without the scientific rigor required to design these algorithms and put them out there, largely driven maybe by economics or other sort of forcing factors. And if they had carefully sat down and thought about this, they wouldn't have designed an algorithm the way they have. So I'll stop there.
Okay. Finally, if there's any other questions in the chat or any more, please bring them in now. We're out of questions now, so I'm going to bring this to an end. I'll give you another 10 seconds just to see if there are, oh, okay, we have a question. So this question is quite a brief, short one. What is the future of AI? Take it away.
Well, it is up to all of us, isn't it? Right? Future of AI is to all of us, like, and I don't mean, I mean very broadly, like, to students, to the lecturers and other people at the university, but us as a society, right? It is up to us, like, like with any sort of scientific, if I can call it, like, effort or tool or whatever we create. It depends on how we generate or sort of create these tools and how we implement and use them, right? And how much care do we put into it. If done properly, like with any other sort of it's called the modern revolution, right? AI is called the modern revolution. Like, with any other revolution, if done properly, you can end up with very good positive outcomes. But we also risk, and as we are seeing this, like with any other thing, with any revolution, there is also this thing of rushing into things without carefully thinking about the consequences of actions. And that can be really bad. So as an AI researcher, I would like to be optimistic and say that if we as a society can think about these problems carefully, good things will come out of it. If not, well, no, I don't want to think about that. I would say, I want to think about that in research and be very careful in what we do. But at the same time, I would like to remain optimistic that the future of AI can be very nice. Thank you.
I like to say that it's similar to what Mohan said, but also from my experience tracking on a longer term a different technology. So when cryptocurrencies like Bitcoin started, it was sort of marginal. There's so many teething problems around how the technology is being used. So I think we should keep in the back of my mind that it's all emerging and there's still so many things to correct. But I personally believe AI is here to stay, and that as we grow in our use and understanding of what we can do with it, it will get better and become more streamlined, and only what's left that's valuable will be taken forward by society in general.
Thank you so much. Okay, so I'm going to bring this conference to an end. Firstly, I just say a massive thank you to our panelists for being here today, for doing this event. Another thank you to Jasmine and to Tom for helping organising and liaising with you to make this happen. Black Voices will be doing several more events, and you can check these out, and they'll be coming, so look out for those. We also have footage from conferences that we have done back in October, about 3 days worth of conferences, so you can see the chat for the links to that. And if you would like to be involved in running and organising further events, if you have any more ideas for events that you would like to see happen, please do contact campaigns@guild.bham.ac.uk. And just a massive thank you to everyone for coming, for attending. Thank you for being here, and thank you to our panelists once more.
Hey, Amira, could I just say one thing?
Yeah.
If you want to learn about AI, machine learning, and all those things, please come study in the School of Computer Science. Thank you.
Yes, that too, everyone. Yeah.
Thank you.
Thank you, everyone.
Thank you.
All right. Bye.